All right, number 2 is slightly less silly, but still feels kind of silly because we already know formulas for finding the area of a triangle. But we still want to see how we could do this by adding up an infinite number of rectangles. And again, we will apply this to situations where it is definitely not silly. Okay, so again, you have a choice here. You can slice vertically or horizontally. You could try slicing diagonally. It just messes with my brain a little. I'd probably then want to tip this triangle so it's sat a different way. So I'm just going to take it as is, vertically or horizontally. Both work fairly smoothly. I'm going to choose horizontally, and I'll tell you why. Although both totally do work. Hold on, see if my pen will work for me. Okay. If I do this, I have a very distinct pattern. Whichever way you want to think about working on this. If you work from the top down, the slice gets gradually skinnier and skinnier and skinnier. Whereas if you slice vertically, the slice is first going to get bigger and then going to get smaller. And that means that I'd actually have to somehow do this in 2 pieces. I would say because there's symmetry, that's actually pretty simple. You can just work your way halfway across and then double your answer. But I'm just going to set this up in a way that I can use one integral to get the whole thing and not have to worry about any of that. Okay, so I'm going to call the height of this thing a delta h. And then I need to work on the width. And in this case, it's not quite as easy as before because the width actually is changing. Oh, I'm getting ahead of myself though. I'm not paying attention to the thing that I said was really important. So I have defined delta h to be a little tiny vertical height, little change in vertical, which means that my h variable better measure something vertical. And again, you get to decide what that is, and there isn't a wrong choice. So pick what you want, measure from the bottom, measure from the top. You will get the right answer. You might have a slightly different setup, but you should still get the right answer. So I'm going to go ahead and let my h be from the bottom. And then, that sort of looks right. I want to start working on the area of that one slice. So I know that its height is delta h. I can temporarily call this w. Oh my god. Middle of a sunny afternoon and I still yawn when I make videos. I don't know what it is about video making. Okay, so it's going to be w times delta h. So h so far doesn't even show up in this other than the delta h part. But it will need to because we're not allowed to have this secondary variable w. We need to relate that back to h. And the way we're going to do that is with similar triangles. I'm going to say I have this little triangle here, and the height of my little triangle is h, and the base of my little triangle is w. And that triangle is most definitely similar to this big triangle, whose height is 3 and whose base is 6. So if I'm looking for h, let's do h to w. Oh, wait a minute, I'm not looking for h. If I'm looking for w, let's do w to h. And then on the big triangle, that will equal 6 to 3, which means that my width, oh, I meant to switch colors, but I didn't, is 2 times my height. The width of the rectangle will always be twice as big, I'm sorry, the width of the triangle will always be twice as big as the distance from the bottom. So back up here, I can say that the area of my single slice is a 2h times a delta h. And then again, the idea would be if we want the total area, we're going to add all of those up, and we're going to let the number of slices go to infinity. And we know probably now that that'll turn it into an integral. So we're integrating 2h dh. And again, our units on that are inches. Okay, so 2h is the width of our slice, and that's in inches. And dh is also in inches. And then we have to think carefully. This will depend a little bit on our variable definition. We defined that h was going to start at the bottom. So we want to slice from the bottom, h equals 0, all the way to the top, which is h equals 3. So again, the limits of integration tell you where your slices actually are. The stuff that you're integrating tells you the area formula, basically. We're trying to find the area of a rectangle, so we're going to see length times width in there. And this means I'm getting an h squared from 0 to 3, which means I'm getting 9 minus 0, which is just 9. And that should be square inches. Inches squared. I don't know why I have this zoomed so far out. And if we look back at our picture, we know that area of a triangle is 1/2 base times height. So 6 times 3 is 18. Cut it in half and get 9. This looks perfect.